What does non-linear mean?
Not straight.
Not straight. Okay? Not straight. Right? It means that whatever the ratio of increasing that's happening or decreasing in data is all over the place. It's not constant. The same thing is not happening. Okay? So it could be going steep, then slow. Right? We talked earlier about making graphs, right? And there was a story about like how somebody walked to the park and then they watched a game for a while and then they ran to their friend's house. Right? No? Something like that. There was a story. And if you picture that graph, right? If you're walking, that's a constant. But if you stop and watch a game, then that graph is not moving anymore at the same speed. Right? And then if you run, that's going to be quicker. So it's going to have a steep slope. Anyway, not just a solid straight line. Yes, question?
Is what we're learning right now going to be on the test?
Yeah.
No, it's just
No, we're just gonna put it in our notes, never use it again. It's fine. Yes, it's on the test.
So there's, up until this point, refocus please. Up until this point, like in coordinate planes, we've worked with linear functions, straight lines. But in 8th grade, we're going to talk about quadratic functions, which is nonlinear, and parabolas. So we're going to put those in our notes. And these are highlighted on page 104. Quadratic. This is when you have an exponent of 2 for your variable. Okay? And then a parabola.
Wait, what is it called?
Quadratic function is our first one, and a parabola is our second. And this is a U-shaped curve on our coordinate plane. Okay? So, an important note, because we're going to be looking at some equations today and trying to determine whether, just by looking at them, they're linear or nonlinear. And when you're talking about an equation, if the function exponent is 2 or more, again for the variable, then the function is non-linear. For example, if you see something like y equals 4x to the third minus 7, x to the third is the variable, which means that it is non-linear because it's 2 or more. So just by looking at this, I can tell that it's not going to make a straight line. Yes?
So if it was y equals 4x to the, x, what's it called, the above the
To the second power.
the second power minus 7, would that mean it would be linear?
That would also not, because it's 2 or more.
Oh,
So if it was 4x minus 7, just 4x minus 7, then it could be. Okay? Then it will likely make a straight line. Yes? Sure. Too close? about there, maybe? Okay? Yes.
If the 3 was a 1, would it be?
So if the 3 was a 1, then it could be linear. So if it's in equation form, you're going to check the exponent. That's one way to check. Another is obviously to look at the graph. If we have a graph, so I'm going to draw 3 graphs. And for the first one, I'm just going to draw a straight line anywhere through it. Obviously linear. Okay? The next one, I'm going to draw a U. This is the parabola. This is an example of a parabola, and it is non-linear. They can go the opposite way too, right? Like an upside down U. So Jackson, these notes are for you, they're not for me. So make sure that you're writing. And then lastly, let's say we have just a shift in our data. So it's nonlinear. So if they've given us the graph, we can tell. We can just look at, so the equation, easy. Graph, easy. Okay, you're just looking for straight lines. The third way that we haven't gone over yet today is the table, where we're going to check for inconsistencies in the table information. So, let's say we have x and y. And for our x, we have 2, 4, 6, 8. And for our y, we have 10, 7, 4, and 1. So for a table, we need to check the ratio, right? This is where we make the fraction. Okay, ratio. I'm going to use the ratio and count the distance. So that it's clear for this one is when you want to go like this. From 2 to 4 is 2. From 4 to 6 is 2. From 6 to 8 is 2. From here, we're going down 3, so -3. Then from 7 to 4, we're going down 3 again, so -3. From 4 to 1, down 3. So our ratio for each of these is 2/3, a -2/3, right? So this is not the type where you just put the 2 over the 10 and reduce it down and check. Do we understand the difference? So this is why we want to put this in our notes with some sort of wording that's going to help us. So is this, since everything was the same, is it linear?
Yes.
Yeah. Since the ratio is the same, this is an example of a linear table. Yes, ma'am.
How do you know to do that instead of doing the 2 over 10?
So the 2 over 10 is talking about, that's a great question. It's talking about proportional relationships. So if the word relationship is in it, you can do it that way. And if it's a function, if we're talking about linear or nonlinear, you're going to want to do it this way. So those, you might want to write that as a note, right? Relationships, if you're talking about the relationship, you can just go to the side and do the number on top of each other and reduce. But if it's asking about linear or nonlinear, you want to check the change. Yes, ma'am.
Could you also reduce if it was relationship?
Yes, always reduce. Okay, let's do another one like this. Let's say for our x, we have 1, 2, 3, 4.
The first thing, how'd you get a negative 2 for it?
So since it went down from 10 to 7, that got smaller, I did negative 3. So the negative I made, right? Because that, to show that I went down instead of up.
So that's gonna be negative 2 here.
So then it makes the whole thing negative. Okay? Okay, for my y's, let's say I have 1, 8, 27, 64. So on the left side, I'm going up by ones. If I'm checking the change, 1, 1, 1, 1. And on the right, I went up 7. Then I went up, I think 19. And then I went up 37, I think.
Yeah.
And so if I put these into fraction form, I have 1/7, then 1/19, and then 1/37. What can you tell me about this information?
It's not linear.
Yeah, this is not a straight line. Okay, are you guys ready to try a couple on your own?